21st question says you have e power 2x times sin x. And how do we handle this? Okay, e power 2x sin x. The way of handling this kind of expression is, can we solve this again with the help of something called the ideas that we have just discussed? E power x times fx plus f prime x. You would realize, okay, this will not be easy. So in that case, there's another idea actually that will be useful over here. Let us write I as e power 2x into sin x dx and try to integrate this using pi parts, right? Try to integrate this using pi parts. For pi parts, this is exponential function, this is trigonometric function, and IIT tells me that exponential will be the second function. Exponential and trigonometric, exponential will be the second function. So this will be taken integration and this will be differentiated. So that becomes, okay, I is this particular function, that is equal to first function times integral of second function e power 2x by 2 minus integral of derivative of sin x, which is cos x, times e power 2x by 2 dx. Okay, what does this become? This is e power 2x by 2 times sin x, and there's a minus 1 by 2 over here, and the integral you have e power 2x times sin x dx. Oh, there's no sin x, there's a cos x over here, not sin x. Cos x. E power 2x cos x is what you get. Okay. If you see this particular integral over here, this is again similar to this, right? Similar to this only, because at this stage we thought of applying by parts. We reached this stage. Again, we'll think of applying by parts over here and consider the first function and second function. The first function will be this cos x. The second function will be this e power 2x, right? And with the help of this, I write I is equal to e power 2x by 2 sin x minus 1 by 2 is there, okay? In brackets, what you'll get, first function, which is cos x, times integral of e power 2x. Integral of e power 2x is e power 2x by 2 minus derivative of cos x, which is minus sin x. Integral of e power 2x, which is e power 2x by 2 dx is what I get in the bracket. Please take a look at that. Take a look at that complete expression. What I have done over here is first function times integral of second function, that's the first step, minus derivative of cos x times integral of e power 2x, which is there. I applied by parts on this. Now once you reach this stage, the thing simplifies to what? This is e power 2x by 2 sin x minus, this is 1 by 2 into 1 by 2, which becomes 1 by 4. So e power 2x by 4 cos x is what I have. Do you observe that? Yes. And this minus 1 by 2 comes over here. Minus 1 by 2 minus minus. 3 minuses are there. So, okay, there remains a minus over there. Then you have 1 by 2 and a 2, that becomes 1 by 4. Integral of e power 2x times sin x dx. Do you observe this? Right? This is important to observe. Once you observe this, this is e power 2x times sin x, and once again I reach an integral of this form, or is it of this form, or is it exactly same? E power 2x times sin x dx. This is integral, and this integral has been called I. We have reached that same stage. Are we moving in a circle? No, actually we have reached to a conclusion at this stage. What can we write it as? This is I, which is equal to e power 2x by 2 sin x minus e power 2x upon 4 cos x. And what is this? This is minus 1 by 4 is okay. This is nothing but that same I that we started with, yes. So I'll write it as I. What's the harm in that? There's no harm in that, yes. Okay, that's pretty interesting, because what you now have is I in terms of I, and we can maybe rearrange and get I from here. This is a linear equation in terms of I, yes. Integration, what happened to integration? Oh, we have been integrating, but we did not integrate anything over here. No, but this is I, that same I, right? So actually we have reached a stage where we can replace this integral with I, and we have reached the final integral value. This 1 by 4 comes over here, becomes 1 plus 1 by 4, which is 5 by 4. I is equal to e power 2x by 2 sin x minus e power 2x by 4 cos x. Plus a constant of integration will have to be introduced over here. And why do you integrate insert a constant of integration at this stage because we are writing final integral. You remember, you recall, in by parts, while applying by parts, in this we do not write the constant of integration. In this we do not write the constant of integration because it becomes redundant. But if we replace this particular integral with I, we'll have to introduce a constant of integration. As simple as that. Let's call that constant of integration C1 for now because I is still to be found. I will be equal to multiplying by 4 by 5. So 4 upon 5 will be 2 by 5 e power 2x sin x minus 1 upon 5 e power 2x cos x plus 4 by 5 C1, let's call it C. 4 by 5 C1, let's call it C. That's the required constant of integration. This is my final answer for this question. Or you can write it in another form as, I'll explain, another form as, take a e power 2x common and take a 5 in the denominator common. What you get is 2 sin x minus cos x plus constant of integration is what I see. This is what I have. E power 2x by 5, 2 sin x minus cos x plus c. Now this is another interesting formula which we'll discuss in the live session, right? We'll leave this for the live session, right? We'll discuss this formula there, where we have e power x sin bx, something of that sort, right? So such kind of results can be obtained with that formula. Such kinds of questions can be handled there. But this is the method by which we get this answer over here. And that's a complete solution of this 21st question.